and I have evaluated only one copy because that was in the PDF format, and the other copies.
ये लोग ना भड़काना चाहते हैं एक दूसरे के खिलाफ, फिर हम इतने गिरे हुए भी नहीं अपनी जॉब बताने के दूसरे की खाते हैं।
Manju, please switch off your mic.
मेरी नौकरी है ना, अब मैं अपनी नौकरी के लिए मैं
Manju, please switch off your mic.
मेरा काम है, गवर्नमेंट ने ये बोला है जो काम ये बंदा करता है तो ये काम जो रूल है तो उस रूल को फॉलो करो। तो मेरे को बड़े ध्यान रखते हो ऊपर से।
Manju, please.
अगली बार बोलेगी ना लेकिन
if you are getting my voice, then please switch off your mic.
ध्यान रखते हो, आप क्या ध्यान रखते हो मेरा? आपके ये ध्यान रखना बोलता हूँ मैडम। देखो इसीलिए अब नहीं कहेगी दोबारा कि गवर्नमेंट मुझे फर्क नहीं पड़ता।
Manju, please switch off your mic.
पूरी तो बुरी रहेगी, आते हम कट के गिर जाए, मैं सभी कट के पिस जाऊँ, हम क्यों करें? नहीं मैं अगर तुम अगली बार भी बोलेगी कि ये सामान वहां से लेकर अगली बार भी मना ही करूँ।
Manju, are you getting my voice?
मैं सर को बोल दूँ सर, मैडम से बोलिए आप खत्म। मैं प्रिंसिपल को बोलूँगी या सीमा को बोलूँगी? मैं इन लोगों के अलावा किसी और को क्यों बोलूँगी? मैं किसी और को क्यों बोलूँगी? मतलब मुझे जब तुम पावरफुल बने हो, तुम्हारे पास पावर है, तुमसे कहूँगी ना, मतलब मैं
Good evening, Kritika. I have provided you the model answer for the second question that was based on the Supreme Court judgment on the cryptocurrencies. Okay. तो सभी को मिल गया होगा मॉडल आंसर? ओके गुड। एंड सौम्य रंजन एक कॉपी मैंने चेक की है एंड इट वाज ऑफ द सौम्य रंजन, and because it was in the PDF format and it was easier for me to evaluate that in the digital format. Okay, so if any one of you wants that your copy gets evaluated, make sure that you upload it in the PDF format and then send it to me, because I cannot remark on the JPG images. So that is the one problem with the JPG format, and I know how to evaluate digitally, okay, using the Adobe Reader for the PDF format files. सभी को मॉडल आंसर मिल गया होगा एंड ट्राई टू इम्प्रूव अपने आंसर्स को खुद ही रीरीड देम। ओके, अपने फ्रेंड्स को पढ़वाओ, अपने फैमिली मेंबर्स को पढ़वाओ, एंड व्हेन यू विल रीड इट अगेन you will yourself realize that you can improve on it. Okay, so for this process to be successful, you have to be honest to yourself. If you are honest to yourself, okay, you can give the better judgment about your performance. Okay, you are the best evaluator of your performance and you know where your weaknesses are. Okay, other people can also help, but you are the best evaluator of your performance and you are also the best knower of your weaknesses. So we started with the gravitational waves in the last class. Good evening, Pooja. So I told you that gravitational waves, they are an outcome of the general theory of relativity of Albert Einstein. Okay, so in the Newtonian picture, Isaac Newton, he gave a description of the gravity as a force. Gravity is a force which attracts everything towards the center of any celestial body, be it Earth, be it Moon, Sun, or any other celestial body in the universe. Okay, in fact, any mass attracts another mass with a force which is given by the gravitational formula of Newton. Okay, so according to Newton, masses, they attract each other by this formula. So the description of Newton of the universe, it was very apt. Okay, using this description, we have sent the satellites to the space. Okay, we have manufactured the missiles, ballistic missiles, and other things. So Newtonian mechanics, the theory of gravity, it works well. Okay, for all of these. But to describe the universe, the Newtonian picture, it was not very much complete. ठीक है, सो न्यूटोनियन पिक्चर में हम अर्थ के ऊपर होने वाले इवेंट्स को या सोलर सिस्टम में होने वाले इवेंट्स को बहुत ही इजीली डिस्क्राइब कर सकते हैं, लेकिन जब लार्जर कॉस्मोस की बात आती है, कॉस्मोस मींस यूनिवर्स, व्हेन वी टॉक अबाउट द लार्जर यूनिवर्स देन द न्यूटोनियन पिक्चर इट कैन नॉट बी यूज्ड टू अंडरस्टैंड द यूनिवर्स. ओके, हमको कंप्लीट डिस्क्रिप्शन नहीं मिलता है यूनिवर्स का न्यूटन की ग्रेविटी से. There are many phenomena which we cannot understand by the use of Newtonian gravity. So Albert Einstein, Albert Einstein सबसे पहले एक थ्योरी के साथ आए थे 1905 and 6 के टाइम पे, and it was the special theory of relativity. It was the special theory of relativity. And all of you must be knowing one thing about the special theory of relativity. In fact, two things you all must be knowing. First thing is that one is this formula E equals to mc square. Okay, ये सबको पता होगा, E is equals to mc square. Yes, so that formula, it was from the special theory of relativity. Einstein figured it out that mass is a form of energy. Okay, mass and energy, they are the manifestations of the same form. They are two manifestations of the same form. They are basically the single entity, mass and energy, and they are interconvertible, and there are two manifestations of one single form. And second thing was, you must have also heard that nothing can travel faster than the light. Okay, nothing can cross the speed of light c. Or no one can travel faster than the speed of light c. So these two are the outcomes of special theory of relativity. Okay, E is equals to mc square, and no particle or nothing can travel faster than the speed of light. These two are the outcomes from the special theory of relativity. ओके, ये सबको समझ में आया? अगर अब यहां पे दिमाग पे थोड़ा सा जोर डालोगे तो एक चीज हमें रियलिटी, फिजिकल रियलिटी के बारे में एक चीज यहां से समझ में आएगी. ओके, क्योंकि कोई भी पार्टिकल इट कैन नॉट ट्रेवल फास्टर देन द स्पीड ऑफ लाइट. अगर यू आर पुशिंग एनी ऑब्जेक्ट, कितना भी उसको एक्सेलरेट कर दो, लेकिन वो स्पीड ऑफ लाइट से तेज स्पीड कभी अचीव नहीं कर पाएगा. ठीक है, तो इससे हमको एक चीज समझ में आई है, देयर इज समथिंग अबाउट द स्ट्रक्चर ऑफ स्पेस. दिस इज रिलेटेड, दिस इज द प्रॉपर्टी ऑफ द स्पेस. द स्पेस इट विल नॉट अलाउ एनीथिंग टू ट्रेवल एट दैट मच स्पीड. Okay, that is the limit of the speed. कोई भी particle, be it any particle, be it a buffalo, be it a man, or be it anything, any material particle, it cannot travel faster than the speed of light. And this is related because the geometry of the space, the structure of space is such that, okay, it cannot allow any particle to travel faster than the speed of light. ये चीज समझ में आई? क्यों ऐसा क्यों है कि कोई भी चीज स्पीड, लाइट की स्पीड से तेज ट्रेवल नहीं कर सकती? बिकॉज देयर इज समथिंग विद दिस स्पेस. ओके, द ज्योमेट्री ऑफ द स्पेस इज सच दैट नथिंग कैन ट्रेवल फास्टर देन द लाइट. ओके, नाउ अब यहां से एक पॉइंट उठा लो, दैट स्पेस ऑल्सो हैज ज्योमेट्री. ओके, एंड आइंस्टीन ने इसको थोड़ा सा और जनरलाइज कर दिया. आइंस्टीन जनरलाइज्ड इट further and he said that basically we have to talk about space and time as a unit. So he considered space time as an entity. Okay, space and time, they are intertwined, they are interlinked. Okay, so time is also not an absolute quantity. न्यूटन को लगता था कि टाइम एक एब्सोल्यूट क्वांटिटी है और टाइम एक अलग रेट पे चलता रहता है. ठीक है, टाइम इज यूनिवर्सल, बट टाइम इट आल्सो डिपेंड्स अपॉन द फ्रेम ऑफ रेफरेंस. टाइम भी हर ऑब्जर्वर के लिए अलग अलग रेट पे चलता है. इंटरस्टेलर मूवी आई थिंक यहाँ पे काफी लोगों ने देखी होगी. इंटरस्टेलर, ओके, इंटरस्टेलर में देयर इज वन इंसिडेंट, जब वो लोग एक दूसरे प्लेनेट पे जाते हैं और वापस जब अपनी स्पेसशिप में आते हैं तो वो एक अनयूजुअल चीज ऑब्जर्व करते हैं. ओके, सो व्हेन द क्रू ऑफ द स्पेसक्राफ्ट दे विजिटेड वन प्लेनेट, a massive planet, and when they returned back to the spacecraft they realized that okay, there is something fishy. The ages of the crew member, they were very different. The age of the crew member, they were different because time is different for different observers. Okay, so mass, last class में मैंने बताया था that because of the mass of the earth the space is distorted. Not just this space, the time is also distorted. एक heavier planet पे time slowly run करता है. Okay, if you will go closer to the sun. Yes, Pooja. See, if you will go closer to the sun, Pooja, then you will realize that the time there, it will run slower. Okay, the clocks near the sun, they will tick slower. The space is more curved near the sun, and the time runs more slowly near the sun than the earth. Okay. See, let me give you one more example. Okay, there are some particles that are known as muons. These are particles and these are heavier than the electron, and when these particles, they are at rest inside the laboratory. Suppose you are studying these muons inside your lab. Okay, and you are measuring their decay time. Decay time, just time में muons decay हो जाएंगे. Okay, they will vanish. So the decay time when the muons, when they were at rest, and the decay time when the muons were moving inside the laboratory. Suppose the muons, they were moving at some speed which is less than the speed of light. Suppose the muons were moving at a speed 0.6 times the speed of light, and here you are measuring the decay time of muons when the muons were kept at the rest. Okay, so when the muons were moving at the speed comparable to the speed of light, their lifetime, it was larger. They remain alive for a longer period of sorry. So they were alive for a longer period of time. Their lifetime was longer. So इस example को बताने का यही मतलब है that time is also relative. जब वो rest पे थे तो उनका decay time कुछ और था, and when they were moving, their decay time was different because the clocks, they tick differently for one observer which was at rest and for one which was moving. तो इसमें जाने की जरूरत नहीं है. ये एग्जांपल देने का मेरा मतलब यही था कि टाइम इट इज आल्सो रिलेटिव, इट डिपेंड्स अपॉन द ऑब्जर्वर. Okay, because in the lab you are observing two different things. One thing was at rest and one thing was moving, and the clocks, they were ticking differently for the two. Don't go into it. So here we have some facts about the universe. The universe is about 13.8 billion years old. Okay, so the age of the universe is, it is something 13.77 billion years. So that means universe also had a starting point. There is a starting point for the universe, for the birth of the universe, and that starting point, it is famous by the name Big Bang. Okay, so the universe started from a point, and there was a very big blast, and that is known as the Big Bang, and that Big Bang happened 13.8 billion years ago. Okay, so this is also the outcome of the GTR, the general theory of relativity of Albert Einstein. Okay, so as per this theory, the universe expanded from an initial state that was of extremely high density and temperature. Okay, and by one estimate, we have 100 billions of galaxies in the universe. Okay, we have at least 100 billion galaxies in our universe. So questions जो भी होंगे, अगर यहाँ से questions आते हैं, they will be very easy questions. Questions इस तरीके के ही होंगे कि बिग बैंग क्या ये आइंस्टीन की थ्योरी ऑफ रिलेटिविटी से कनेक्टेड है? So answer would be yes, it is connected. Okay, या सिंपली यही आएगा कि क्या टाइम डिफरेंटली रन करता है फॉर डिफरेंटली ऑब्जर्वर्स? Okay, do the time it runs differently for different observers? So questions will be of easy type. So the universe, it originated from a very high density fluid. Okay, from a point, the universe started from a point, and there was a big bang. And here we have some dark ages. Okay, so for some initial millions of years, we have the dark ages because we have no light. There was no visible component of the electromagnetic radiation, so these are known as the dark ages. And after about some time, after about 400 million years, the first stars, they were born. Okay, and then the all other planets and galaxies, they all formed after the Big Bang. So there is also one thing. Okay, the volume of this funnel is increasing, and it shows that the universe is expanding. Okay, the universe is expanding in size. Okay, and the expansion is accelerated. Okay, see, the galaxies, they are moving away from each other, and they are moving away from each other at a very faster rate. Okay, earlier it was believed that by the action of gravity, the expansion, it will stop someday, but that never happened. And the new observations, they tell us that the universe is in fact expanding at a higher rate. Okay, Pooja is typing a question. Pooja, go ahead with the question. I will come to it, Pooja. See, everything that we have concluded, okay, these are either based on the sophisticated mathematical theories or that are supported by physical reasoning. Like we have the GTR, the general theory of relativity, given by the Einstein, and it uses extensive mathematics, okay, logic, and the physical ideas. And also we have the experiments to supplement the physical reasoning. Okay, so the GTR is a physical theory, and then we have experiments which supports the theory. Okay, so the experiments, the observations have tell us that the universe is expanding. You must have heard about the Hubble Space Telescope. Okay, yes, So in the 1998, in the year 1998, from the data of the Hubble Space Telescope, we concluded that the universe is in fact expanding. और साइंटिफिक कम्युनिटी के लिए फिर बहुत मुश्किल हुआ इस चीज को एक्सप्लेन करना, that how can the universe expand, and the scientific community has concluded that okay, there is also some kind of exotic matter, okay, some kind of dark energy in the universe because of which the universe can expand. ओके जो भी फिजिकल लॉज नेचर के हमें पता है, जितनी भी फिजिक्स लगा लो, द यूनिवर्स कैन नॉट एक्सपैंड, बट ऑब्जर्वेशंस दे आर टेलिंग अस दैट यूनिवर्स इज इन फैक्ट एक्सपेंडिंग, एंड फॉर दैट रीजन वी आर नाउ सर्चिंग फॉर डार्क मैटर एंड डार्क एनर्जी. आई विल रिपीट इट अगेन, डोंट वरी. तो कोई भी ख्याली पुलाव नहीं है. ओके, आइदर दीज आर बेस्ड ऑन द एलाबोरेट मैथमेटिकल थ्योरीज, and these theories, they are supported by the experiments. So this is all experimental data that the universe consists of billions of galaxies. There are billions of galaxies in the universe, and each galaxy. Yes, Nikhil.
Sorry, sir, I joined late, sir, because I was not feeling well, sir. I was having stomach pain.
Okay, Nikhil, fine. So each galaxy is a huge collection of gas, dust, and billions of stars. Okay, there are billions of stars within a galaxy. Like our Earth is in the Milky Way galaxy, and in the Milky Way galaxy there are billions of stars, and out of those billions of stars, okay, one star is our sun. Okay, Pooja is saying that in the Milky Way we have 100 to 400 billions of stars, and one such star is the sun. Okay, and sun has a solar system, and in that solar system our Earth is a planet. Okay, so these galaxies, Nikhil, please switch off your mic if you do not have any question.
Yes, sir.
So a galaxy usually consists of a supermassive black hole. We will talk about these black holes. Okay, in the middle of the galaxy we usually have the supermassive black holes, and in the Milky Way galaxy that black hole is named as Sagittarius. Okay, and the Sagittarius, it is billions of times heavier than the sun. So the name of the supermassive black hole at the center of Milky Way galaxy, it is Sagittarius A. These are some of the facts, and ये facts अपनी copy में लिख सकते हो. Okay, if not in the UPSC, they can be asked in the state PSC examinations. So Wajid, you want to ask something? Okay, Subodhi. I am saying that in the universe, okay, in the universe we have billions of galaxies, and each galaxy, it is okay, each galaxy is a huge collection of gases, dust, and billions of stars. So in each galaxy we have billions of stars, and the universe has the billions of galaxies. And out of those billion stars, okay, in the Milky Way galaxy, one star is our sun, and sun has a solar system. There are 9 planets revolving around the sun. Okay, and usually at the center of these galaxies we have a supermassive black hole, and the black hole that is at the center of the Milky Way galaxy, the name of that black hole is Sagittarius. Sagittarius A is the supermassive black holes, which is at the center of Milky Way galaxy. And the mass of these black holes, it is billions of times, they are billions of times heavier than the sun. So here we have some factual information. Yes, Sharda?
No, nothing, sir, nothing.
Okay,
Sorry about that.
it's okay. So here we have some factual information. The nearest neighbor, the nearest galaxy to Milky Way is Andromeda galaxy. And Andromeda is 2.5 million light years away from the Milky Way galaxy. So what is this light year? Light year कौन बताएगा?
So the distance traveled by light in a year.
Yes, Somi. So the light is traveling at the tremendous speed of 3 into 10 to the power 8 meter per second. Okay. And this is basically, this is 3 million, not 3 million, it is 3 lakh kilometers. No, Nathan, there can be several black holes in a galaxy. There can be several black holes, but in one galaxy, we have at least one supermassive black holes. In the center of the galaxies, usually we have one supermassive black hole. Okay, there can be several black holes in one galaxy. So the light moves at the tremendous speed of 3 lakh kilometers per second. And if the light travels at this much speed, okay, so the distance that the light will cover in 1 year is 1 light year. And Andromeda is 2.5 million light years away from Milky Way. Okay, so it will take light 2.5 million years, okay, to reach the light to reach the Andromeda galaxy. It will take 2.5 million years. So जो भी हम टेलीस्कोप से देखते हैं, okay, जो भी लाइट हम आज रिसीव कर रहे हैं एंड्रोमेडा से, that has started 2.5 million years before. So in a way, when we look into the space, we are looking into the past. We are getting the information of the state of Andromeda that was before the 2.5 million light years. And some of the key facts that we find by using the telescopes like Hubble Space Telescope, the Chandra X-ray Observatory of NASA. Okay, and we have the information that universe is expanding and it is getting bigger each day, and it is not only expanding, but it is expanding at an increasing rate. Previously, scientists thought that because of the gravity, because gravity is pulling different celestial bodies towards each other. So after the Big Bang, after the initial push of the blast, the universe was expanding, but there will come a day when the gravity will pull everything together and the universe will start contracting. So this was the previous view of the physicist, but the observations from the Hubble Space Telescope, okay, they find out that the universe is in fact expanding and the expansion is accelerated. The galaxies, they are moving away from each other and the rate of receding, it is increasing day by day. And you all of you know that sun is a star, and inside the core of the sun, the hydrogen gas, the hydrogen is fusing to form the helium. And once the hydrogen is over, the fusion of helium will start and ultimately it will change to different elements. And the nearest star to our sun is Proxima Centauri. Proxima Centauri is the nearest star to our sun, and this Proxima Centauri is 4.25 light years away. Okay, so the nearest galaxy to Milky Way is Andromeda, and the nearest star to sun is Proxima Centauri. Nikhil, you have any question?
Sir, but nearest the sun, people were saying that there was Alpha Centauri, sir. No, sir. Then the Proxima Centauri was third star, like that they were saying.
Proxima Centauri is the third star, you are saying?
No, sir. Yeah, in one book I read that first is sun, then the second nearest star is Alpha Centauri, then is Proxima Centauri. Like that I heard, sir.
Okay, I will verify it. I will verify it tomorrow, don't worry.
Thank you, sir.
Okay, Nikhil. So you are asking how do we know that the universe is expanding? We know all this from the observations, from the data that we have collected from different telescopes. Okay, the network of different telescopes across the world. Okay, Nikhil, Pooja has given the answer to your query. Alpha Centauri is closest to Earth and Proxima Centauri is closest to Sun. Okay, Nikhil?
Okay, sir. So the second star which is closest to Earth is Proxima Centauri, sir.
Yes.
After the sun. After the sun.
After the Sun, yeah, after the Sun it is Alpha Centauri.
Oh, okay. Thank you, sir.
Okay.
Thank you,
Okay,
sir.
Nikhil. So we are gathering data from different telescopes, and that data has given us information that the universe is in fact expanding. So Einstein, he came up with his general theory of relativity in the year 1915, and this theory is basically the theory of gravity. And in this theory, Einstein explained that gravity is not a force. Okay, we can consider gravity as due to some distortion of space and time. Okay, the distortion of space and time, it manifests itself in the form of gravity, and this space time, it gets distorted due to the massive bodies. And in fact, the Einstein said that the space time, the fabric of space time gets distorted because of energy and momentum. And in the Einstein's picture, mass and energy, they are equivalent. Okay, so mass ko energy ko ek hi baat hai. So because of mass, because of energy, there will be distortion of the space. So gravity is related to the geometry of the space. Gravity is not a force, and in fact the gravity, it is related to the geometry of the space. And this theory, it was very successful in explaining the planetary phenomena and the phenomena that were happening in the larger cosmos. Okay.
Sir,
Yes, sir.
sir, I request एक बार sir, if you can please explain this once again, sir, due to distortion of space and time, sir, due to massive bodies, sir, ये समझ में नहीं आया sir.
ओके अर्पित, एक आर्ग्यूमेंट मैंने दिया कि ओके, दिस स्पेस आल्सो हैज सम काइंड ऑफ ज्योमेट्री. ओके, दिस स्पेस हैज सम ज्योमेट्री. देयर इज सम ज्योमेट्रिक स्ट्रक्चर ऑफ द स्पेस, एंड दैट ज्योमेट्रिक स्ट्रक्चर ऑफ द स्पेस, it changes its shape. The geometry changes because of the presence of mass and energy. Mass, energy and momentum. Mass and energy are the same thing. the geometry of the space, it changes because of the presence of mass or because of the presence of energy. So this is the argument. In the last class, I also told you that when you throw a stone, it follows a parabolic path. And in the Einstein's picture, in the GTR, because gravity is not a force, so why this stone is following a curved path? This stone is following a curved path because the space is itself curved. Okay, it is related to the geometry of the space. कुछ समझ आया आपको?
Yes, sir. Yes, yes. Thank you.
Okay. So the ideas, these ideas that were presented by Einstein, they were very radical. Okay, they were very radical, and for some people, they were defying the logic. Okay. We discussed the cognitive tasks. Cognitive tasks when we were doing the artificial intelligence, then we have covered these cognitive tasks. And cognitive tasks, the humans, they learn from their experience. Okay, so while living on the earth, we learn from our experience, and we make a notion of the physical laws for the events that are happening around us. And we never observed that we never observed the particles which can move closer to the speed of light. So we never observed about these the geometry of the space-time. क्योंकि हम डेली लाइफ में ये फिनोमिनास कभी ऑब्जर्व ही नहीं कर पाते, सो हमारे लिए ये इलॉजिकल है या रेडिकल आइडिया हो सकता है, बट बेसिकली दिस इज रिलेटेड टू द स्ट्रक्चर ऑफ द यूनिवर्स. सो it takes time to absorb the new ideas. And Einstein, his intelligence lies in that he observed the structure of the universe and he identified these limits about the speed of light and the geometry of the space and time. So that was his genius, and that is why Einstein is regarded as the highest mind, the highest mind that has lived on the earth. So geometry of the space-time, gravity is not a force and gravity is related to the geometry of the space-time. And because of the presence of the mass, suppose this is any massive body, then because of the mass, there is distortion in the fabric of space-time. So this is the artistic representation of the space-time. This is the fabric of space-time, and in the fabric of space-time, we have a distortion. We have a distortion, or we have a sag, or we can even say we have the curvature. We have the curvature in the fabric of space-time. So that curvature is because of the presence of energy, mass, or the momentum. Okay. So this is Albert Einstein, and in the same theory, from the general theory of relativity, Einstein predicted the presence of gravitational waves. He predicted the presence of gravitational waves, but later in his career, he was not comfortable about the idea of the gravitational waves. अब इन्होंने प्रपोज तो कर दिया क्योंकि इनकी थ्योरी से ये चीज सामने आ रही थी, लेकिन उस टाइम पे इनको भी शायद लॉजिकल बाद में लगने लगा था, और आइंस्टीन को लगने लगा था दैट ही वाज डूइंग सम काइंड ऑफ ब्लंडर. But Einstein was right, and in the year 2015, we directly observed the gravitational waves, and in the year 1970, we indirectly observed the presence of gravitational waves. So gravity is related to the structure of space-time, and the curvature of space-time, it depends upon the energy and momentum, which is related to matter and radiation. So So what are these gravitational waves? Gravitational waves, these are the ripples in the fabric of space-time, and this is very much similar to the waves that are formed, okay, inside a pond. Inside a pond or inside a water tub. So these waves are similar to those waves, and these are the waves in the fabric of the space and time. Okay, but to observe these waves, okay, these waves, they can originate from the very big events in the cosmos. So the big events that can happen in the cosmos, only they can generate the waves which can be detected. The detectable waves can be generated by some huge events in the universe. Cosmos is basically the universe. Cosmos is universe. So when the gravitational waves pass through the space, or they pass through any body, they squeeze and they stretch anything in their path. Okay, you can imagine it like that. If there is anything and the gravitational wave is passing through it, if you have put a scale in the path of the gravitational waves, then it will shrink and it will expand. It will shrink, it will expand. Because the space is itself expanding, okay, the space is stretching. So things, they will stretch and they will squeeze as the gravitational waves pass through them. Okay, and the gravitational waves, they are incredibly fast and they travel at the speed of light. So we have the two properties of gravitational waves. They will squeeze and they will stretch everything that will come in their path. Okay, and they travel at the speed of light. Okay, and they do not reflect, or they are not even obstructed by anything. Nothing can obstruct them. They are not obstructed by anything, and neither they reflect from any kind of boundary. But in the case of light waves, or in the case of waves originating in a pond, or the waves originating in a tub, okay, they can be reflected from a harder surface, okay, and they cannot pass through any surface. But the gravitational waves, they can pass through anything. Nothing can stop them. ये चीज सबको समझ में आई? ओके, सबको पेरिस्कोप के बारे में तो पता होगा. No, Kritika. Vacuum is nothing. These are the space waves. These are the waves in the fabric of the space-time. So in the higher physics, vacuum is nothing. There is, okay, and they will say that the space is not nothing. Generally, we have a notion that nothing is space. Yes, Kritika. They exist around us, they can pass through us, okay, and we may not feel that, because the events from which these waves are generated, they are located very far away from us. If you will go closer to, okay, the source of any of these waves, okay, so these waves will rip apart us. They exist everywhere. Nothing can hinder them. And I was giving the example of periscope because in the case of periscope, Okay, we can change the path of the light. If we are observing a thing that is placed here, then light will originate from it and it will reach our eye. Okay, we can change the path of the light, but nothing can change the path of the gravitational waves. And using this property of the light, we can peek around the corners. Okay. Nothing can stop the gravitational waves. Yes, Nikhil?
Sir, that means light waves can be changed and they can be controlled, but gravitational waves, they cannot be changed or they cannot be controlled, no, sir?
Gravitational waves, you cannot manipulate them as of now. We do not have any technology to manipulate them. But one property of the gravitational waves is, okay, they are not obstructed by anything.
Yes,
Because these are the space waves, and you, okay, आज से पहले you were considering space as nothing.
yes, sir. Yes.
When we have nothing, then we have the space. But the physicists now believe that this space is not nothing. The space is not nothing. Because these waves, okay, these waves, these are the ripples in the space, in the fabric of space-time. So we expect that detectable gravitational waves will be generated by the massive bodies. Massive bodies, okay, that have the enormous energy. Enormous energy, okay, enormous mass that can generate these waves. Now imagine, okay, 5-6 लोग, yes नितिन, 5-6 लोग अगर किसी स्विमिंग पूल में जा रहे हो, 5-6 दोस्त, एंड सबसे बड़ा स्प्लैश कौन सा बंदा प्रोड्यूस करेगा स्विमिंग पूल में? ऑब्वियसली जो सबसे ज्यादा हैवी होगा, है ना, सबसे ज्यादा मेजरेबल, सबसे ज्यादा बड़ा स्प्लैश सबसे ज्यादा हैवी बंदे का होगा. इन अ सिमिलर वे, जो स्पेस टाइम का फैब्रिक है, okay, that will be disturbed in the most violent manner by the most massive objects. And Nitin is right, those massive objects are generally the black holes. Okay. So such kind of events produces these waves, and we detected such waves on the Earth in the year 2015. So gravitational waves, they are usually formed by one of the following waves. One is the explosion in a star. If there is explosion in a star, then the gravitational waves, they can form. Or when the two big stars, they are orbiting around each other, then also the gravitational waves can be generated. Or by the mergers of the black holes and even the neutron stars. I will explain what the neutron stars are. Okay, so because these are the heavier objects, and because of these objects, the gravitational waves, they can generate. Okay, so a binary system is when two stars are, they are rotating about a common point. If two stars, they are rotating around a common point, then this is known as a binary system. And when the two massive objects, they are rotating around a common point, then we can expect that the fabric of space-time, okay, they will jolt the fabric of the space-time, and the gravitational waves will be generated in such an event. Okay. So what is this supernova? In the right portion of the slide, here I have shown a white arrow, and this white arrow is pointing towards, okay, a very faint white star. Okay, and then the star explodes, and this is the glow of the exploded star. So this explosion is known as supernova. When a star explodes, and when the star explodes, we have these bright events, and these bright events, they can last for 2-3 days. And by the use of the powerful telescopes like the Hubble Space Telescope, the Chandra X-ray Observatory, okay, so they are looking for these kind of events, and we can get a lot of data, a lot of information about the universe. So this is one such explosion. This is supernova, when a star explodes. Supernova explosion can result, yes, Nikhil?
Sir, our sun does not become supernova, no, sir?
Our sun does not have enough mass to become supernova.
Yes, sir, yes, sir, yes, sir.
Okay.
Yes, sir.
Okay. And even if the sun had the mass to become a supernova, even then we have the billions of years with us. Okay. And the black holes and the neutron stars, generally towards the end of a star's life, okay, the supernova events happen towards the end of a star's life. And after the supernova, either it can convert into a neutron star or it can convert to a black hole. I will cover it, don't worry. So in the supernova event, what happens? See, every star, like our sun, every star has a core, and outside the core, we have the rest of the star. Then towards the end of the star's life, most of the fuel in the core, it gets burned. The fuel burns inside the core. Like in the sun, we have currently the hydrogen, and the hydrogen will first convert to helium, and then the helium fusion will start. So that is the fuel. So at this end of the star life, the core of the star is deprived of this fuel for the fusion. Okay, then in that event, it will start eating mass from the surrounding layers of the star. It will start taking up mass, okay, taking up matter from the surrounding layers. And in that event, because of some instability, when the star starts to eat up its own mass, then in that event, supernova happens. It explodes because of some instability. So when the star explodes, its outer layers, okay, they fly away. And a huge flash is generated. The outer mass, it flies away. And basically in the explosion, the star debris and other elements, they are ejected into the space. And most of the elements that we now see on the earth or that we have observed in the universe, they have originated from the core of the stars. Okay, because inside the core of the stars, the hydrogen is turning into helium, helium is turning into something else, and then something else will turn into something else. So most of the elements, they have originated inside the cores of the stars. And that is why we are interested in such events, because they will tell us so much about the universe, so much about the structure of the universe. So basically, I told you about the big data, all the observatories around the world, these Hubble Space Telescope and all other observatories, they are gathering data about the universe, and there is a core team of the scientists from each country who are observing this data, and our understanding of the universe, okay, it is getting clearer and clearer each day. So gravitational waves, they will be either formed by a supernova, they will be formed by the orbiting of two stars around a common point that is known as the binary system, or by the merger of two black holes. If the two black holes collide, then we can expect the formation of gravitational waves. Okay, and basically in these events, we will have the detectable gravitational waves. In all other events, the gravitational waves will be formed, but we cannot detect them. So there are two categories of black holes. We will discuss black holes in little detail. For now, you can understand this, that the black holes, there are two categories of black holes. One are the supermassive black holes, which are 100,000 to billions of times massive than the sun. And other black holes, they are a few solar masses. Few solar masses means 5-10 times the mass of the sun. So either we have the light black holes. Light black holes mean whose mass ranges from 5 to 10 solar masses, and either we have the supermassive black holes. Okay, the left picture is the artistic description of the black hole merger, and the right one, this right picture, it is the first picture of the black hole. It was released recently. Okay, and we will discuss about it tomorrow. So किसी का कोई क्वेश्चन हो तो प्लीज पूछो. This is the real picture of a black hole. Yes, Nikhil?
Sir, some people say that black holes have more gravity, so they will pull people towards, and when we go into the black holes, our body will get, tore apart like that. So many people are saying. Is it true, sir?
Yes, Nikhil, it is true. See, inside the black hole, the space and time, it is infinitely curved. So, okay, your body, it will stretch and it will be squeezed because of the gravity. If you will fall into the black hole, okay, you will be stretched and simultaneously you will be squeezed by the gravitational force. Okay.
Okay, sir. Thank you, sir.
Any more question?
Sir, that means it has more gravity than Earth, sir.
Sorry, Nikhil?
Black hole has more gravity than Earth, sir.
Yes. See, black hole, they distort the space infinitely. Okay. And when the space is distorted infinitely, the space has the infinite curvature, then the gravity is also infinite. Or in the other picture, we can say that the gravitational force is very intense. In the picture of the Einstein, the space is very twisted and the space is infinitely curved. Okay, that will impact your body. And if we consider gravity force as the Newton did, then the gravitational force will be very huge and the gradient of the force will be different. Your body will be stretched and it will be squeezed. Okay?
Thank you, sir.
Okay, Nikhil. Any other question? Supernova, basically, Nitin, supernova is an explosion, and that explosion happens at the end of a star life. Okay, as the star ages, then in the later part of the star's life, the supernova explosion happens. Supernova is an explosion. Manju, you have why light around black hole? Manju, that light is not of the, okay. When the black hole, it sucks up matter from the surroundings, then in the process of accretion, there is a process known as ACCRETION. Accretion means when the black hole eats up the surrounding matter. Then in that process, okay, because of the acceleration of the masses, the light glow is produced. This light is not originating from the black hole. Be very clear. This is the accretion disk. Okay. Can we end the session for today? Be sure that that light is not originating from the black hole. Okay, so we will continue from here tomorrow. And till then, bye bye. Take care.